Hello everyone, this is Kusal Vandari and I'm going to present a student-centric ride-sharing application for the database project I'm working on. And the presentation covers the design and implementation of a ride-sharing platform tailored especially for the students. And the system facilitates shared transportation by connecting student drivers and passengers, supporting scheduled and on-demand rides. So the key feature includes the KYC verification, user registration, rider management, and payment tracking also. And this presentation will also go through the entity relationship diagram and the third normal form logical design of our student-centric ride-sharing application. I'll explain what every box and line means, why we split the data, and why we did that, and how this design prevents anomalies and keeps the platform secure and scalable. So for the project review and objectives, our focus is on developing a reliable and secure ride-sharing platform designed for student especially. And then the key features involves the user roles for drivers and passenger both, and ride scheduling and KYC verification for the genuinity of the consumer who is using the ride sharing application, and the payment tracking too. So the goal is to enhance the convenience and cost effective rides with the carpooling among the students. So our entity relationship diagram you are seeing on the screen has the center table named user entity. Everything radiates from that. Lines point to or outward to role specific tables like driver details, passenger details, and downward to the transactional tables such as ride and ride request, and sideways to supporting tables like vehicle, payment, KYC verification, and messages. The arrow represents the foreign key relationships, solid arrows for required links, open arrows for optional ones. Logical database design up to 3 and normalized third normalized form works as the user table has a UUID primary key, their name, email, password, hashed password, plus a role enum that can be admin, driver, or passenger, and a KYC status. Notice the one-to-one arrows from user to driver details and to driver details. That means a driver has exactly one driver detail row, license number, rating, years of experience, while a passenger has exactly one preference record. Storing role specific attributes in separate tables keep the base user record slim and avoids lots of non-label columns. And the role-based design, as we talked, is admin, driver, and passenger roles with flexible and secure data management. So our visualization of database schema is like this. It has a table, and each table has the various entities like tables. The schema diagram details table structures, primary and foreign keys, and attributes relationships, providing a blueprint for implementation. The design support efficient data integrity and query performance as well. So this is how the user table pulling its accounts UID, full name, role, KYC, audience immediately seen the mix of admins, drivers, and passengers, and who still needs verifications. Next, I pivot to driver details, selecting a driver license, number plate, average rating, and years of experience. This is how quality metrics are stored separately. Usually highlighting a preference string that says quiet or music, and explain how this powers personalized matching. From people we move to assets, a simple query on vehicle reveals every car's make, model, plate, color, and capacity, illustrating our one-to-many relationship between drivers and vehicles. The centerpiece is the ride table, where I filter on status completed to show pickup and drop-off coordinates, timestamps, and fares, proving that the schema captured all trip telemetry and revenue. I contrast that with the ride request. Scheduled, repeatable journeys are handled by scheduled ride. I fetch open rows to show origin, destination, departure time, and remaining seats. Then surge to the junction table, schedule ride passenger to demonstrate how many to many memberships are enforced. One query surface says who has booked which shuttle. So monetization appear when a query payment, retrieving the amount, method, and success status. So finance teams can audit revenue streams in real time. Regulatory compliance is showcased through KYC verification by selecting submissions that are still pending or rejected. I illustrated our audit trail and escalation over. Key SQL queries explained. We have like driver and vehicle details, which will like list all drivers with their vehicle information for management and verification. Likewise, passenger preferences identifies passengers preferring quiet rides to enhance user experience. Completed rides and fares retrieves completed rides and associates fares for reporting and billing. And KYC verification status, if the driver's latest KYC status to ensure compliance and security of the travel made using through the application. This involves the query from 15 queries I have done so far. So the first one shows the drivers and vehicle details. The first query joins user, driver details and vehicle. We pull the driver name, license number, and every plate color and they're registered. Query 2, passenger who prefer quiet rides. Here we look for passengers whose passengers text contains the word quiet. The market team can target these users with silent ride options, and driver who advertise quiet cabins can filter on this list. Completed rides and fare accounts. This query filters rides rows where status completed and join back to the driver's name, and then feeds the monthly earnings dashboards. Drivers KYC status. Compliance wants to know which drivers are fully verified. We join users to KYC verification and show the latest status: verified, pending, or rejected. Any driver stuck in pending for more than 48 hours triggers a strike alert. Recurring scheduled rides. Students love predictable commutes, so this query fetches scheduled rides flagged as is recurring. True. So we surface origin, destination, and driver testing, letting passengers subscribe like a bus. And on the query 6, we have passengers with ride request using distinct. List every passenger who has ever submitted a ride request. Ride request status by passenger. Drilling deeper, the same join shows each request status and timestamps. Driver rated above 4.5. We rank drivers quality by filtering drivers details rating greater than 4.5. These top drivers got priority placement and badges in the app, driving a very vigorous feedback loop. Ride coordinates with passenger. For geoanalytics, we select pickup and drop off latitude and longitudinal plus the passenger name. Plotting this on a heat map shows high traffic corridors and helps optimize future carpool routes. Scheduled rider currently open. Operation need a real-time list of scheduled rides that still have seats. We pull every route where status open, exposing seat inventory to the mobile app. Counts of ride request by status. A simple group by on ride request status gives counts of pending, accepted, and rejected request. Product managers watch this ratio to tune acceptance thresholds and notification timing. Completed ride totals per driver. Aggregating completed rides grouped by the driver gives a leaderboard of productivity. Query 13. The rides sorted by fare, high to low. Ordering rides descending by fare highlights premium tips, long distance, or the short distance. Admin users. Security audits begin with a query that lists everyone whose role admin. And finally, the 15th query, passenger with no ride request. Finally, an anti-join shows passengers who signed up but never placed a request. Marketing can send a latest take your first ride, get $5 off kind of campaign targeted precisely at this segment. Coming to the challenges, learning, and conclusion. The challenges what I have encountered was managing complex schema, relationship, normalization, role-based logic, and payment integration. And the learning outcomes that I have gained is practical experience with the Prisma, PostgreSQL, normalization, modeling, and SQL query. And finally, to conclude this presentation, this project successfully delivers scalable and secure ride-sharing backend, meeting all specified requirements, making the students and rider a good platform and a secure platform to have a ride which will be beneficial for the students with the low shared cost sharing basis. Thank you.